In Chapter 5-2, we're looking at problems related to the addition property of probability and also the issue of complement events. So, problem number 35 on page 217 has the following: car repairs. Let E be the event that a new car requires engine work under warranty, and let T be the event that the car requires transmission work under warranty. Suppose the probability of E equals 0.1, the probability of T equals 0.2 or 0.02, and the probability of E and T occurring is equal to 0.01. Question A. Find the probability that a car needs work on either the engine or the transmission or both. From the addition rule, we have the following. The probability of E or T is equal to the probability of E plus the probability of T minus the probability of T and E. So we just plug in the numbers. We have 0.10 plus 0.02, and we subtract 0.01 and we get 0.11 or 11%. Question B is find the probability that a car needs no work on the engine. So no engine work is just the complement of the engine work, those that need working on the engine. We call that P prime, which is equal to 1 minus the probability of engine work, which is 1 minus 0.1, and that gives us 0.9 or 90%. So the probability that a car needs no engine work is 90%, and that's pretty good. In problem 41, again, we look at contingency tables to look at our frequencies. In this problem, 41, page 217 of 6 children, there are 25 students in Mrs. Bush's 6th grade class. On a cold winter day in February, many of the students had runny noses and sore throats. After examining each student, the school nurse constructed the following table. So the table that we see is sore throats, which is one variable, and the other variable is runny nose. And then, of course, in all contingency tables, we construct the total columns, which are called marginal totals. And now we can answer some of the following questions. So find the probability that a randomly selected student has a runny nose. So the probability of runny nose, right, is equal to 18 over 25. That's the total column. That's under the total column for runny noses along the row for runny noses, and we get 18 divided by the total, which is 0.72. So the probability that a student has a runny nose is about 72%. Then it says find the probability that a randomly selected student has a sore throat. Well, we go down the column of sore throats. There's the total for sore throats, and we divide it by the total number of students, and we end up with 10 over 25, which is 0.4 or 40%. Then it says find the probability that a randomly selected student has a runny nose or a sore throat. Well, from the addition rule, right, we get the following. We add the probability of a runny nose plus the probability of a sore throat, and we subtract off the intersection of sore throat and runny nose. There it is. Sore throat and runny nose is 6 divided by 25. When we subtract that, we get the probability is 0.88, or 88% of the students has a runny nose or a sore throat. That's quite a few. And then it says, find the probability that a randomly selected student has neither a runny nose or a sore throat. Well, we could do that in one of two ways. We could see the intersection of no sore throat and no runny nose and divide it by the total, which we did here. Okay. Or it could be the complement of part C. So the complement is 1 minus 0.88 is equal to 0.12. So either way will work. You can find either the complement of the problem in part C, or you can find it in the intersect rule that we've shown you here with contingency tables. So that's the end of chapter 5.2 on the addition rule, and now we'll be looking at problems in 5.3.